Hi, and welcome to Geeks for Geeks. So, just let me see why this flickering thing is happening. Yeah. Okay. So, hi, and welcome to Geeks for Geeks. Today, we would be discussing the post contest analysis of Geeks for Geeks Weekly Coding Contest 83. So, Happy New Year, everyone. Okay. So, what was your score? Can you quickly tell me your score? And there is a delay of 1 or 2 minutes because I don't know why my Wi-Fi went down at sharp 8:30. I don't know why. Yeah, but today, okay. Okay. So, what was the score for you guys? Today's problem was a little bit on the easier side. I don't know. I think it's because of the new year. Okay. So, tell me. So, am I audible as well as equally visible? I don't know. What is the scenario? Just let me see. Okay. Easier side. I don't know. I think. Okay. But on the verge of cracking was getting. You are lagging. Okay. Just let me connect. Okay. Now you shouldn't face any lagging. Okay. Fair enough. Yes, now it's fine. Okay. By the way, Happy New Year, everyone. So, everyone is out there coding still? You ain't out enjoying in the party or all? Or done with the partying thing? Now, okay, sir. Yeah, I connected to the personal hotspot of my phone. Okay. Thanks a lot, Harleen. Okay, Harsh. Last question was not dynamic programming. Okay, I think we can start. Let me just share. The first problem was high frequency. Now, please tell me the next problem because I didn't give the contest, so I'm not aware of it. So quickly read the problem again in just 1 or 2 minutes, recapitulate it, and then I would start. Okay, quickly just recapitulate. Happy New Year, Yash. Just let me restart the router. I think that would solve the issue. Okay, I think that would solve it. Happy New Year, sir. Chalo, I think we are good to go. I would just stop the screen sharing. Okay, the first question was on the easiest side. Let me just entire screen turn on DND and it's done. Okay, So the first problem was on the easier side. What you were told is you were given a string and you need to find the character with the maximum frequency. Okay, you need to find the character with the maximum frequency. The next constraint over this is suppose there are a with a frequency of suppose 23 and there is b with a frequency of again 23 and there are only two. So now a and b both are the maximum one. So if both exist, then you need to report the lexicographically smallest. What do you mean by lexicographically smallest? Lexicographically smallest means in the dictionary order that value should come first. So in the dictionary order, A comes before or B comes before? Obviously A. That is why the character A would be your value. So I would just write lexicographically small. Okay. Lexicographically smallest value that is having the maximum frequency. Fair enough. So now finding the dictionary order is okay. You can just sort it and then you would be told what is the smallest one. Okay. But the main question here is how to solve it. To solve it, if you just remove the lexicographically thing, what you can do is you can just see to it that I want the character with the maximum frequency. If I want the character with the maximum frequency, let's visualize it. Okay. Let's suppose there are five players. Okay. Suppose this is Kohli. This is Mahendra Singh Dhoni, Mahi. And suppose this is Yuvraj. Okay. Suppose I ask you that out of these three, who has the maximum run scored in cricket? Okay, suppose I ask you. So what will you ask? You would ask me that what was the score of all the person. So you would first have the score of all the person. Suppose King Kohli made it to 99. Mahi made it to 101. Yuvraj made it to 56. So now you would start the comparison and you would return the largest value. So you first need the frequency of all the characters, then you would find the maximum one. All the maximum one, you would just sort it and report the first one. Is this easy or not? Give me a quick yes or no. Very easy. First, I would count the frequency. After counting the frequency, I would just move forward, sort it, find the first value, and I can count it using map also, as there are only 26 characters, so that won't make a difference. And if you're aware of ASCII values and all, you can move forward and use arrays. That is much more efficient, and this would be the intended solution using the given interview. So just give me quick zero or one, and then I would quickly move to the implementation because this is an easy problem. Just give me a quick one. Give me a quick one. Gave my first contest today. So how was it, Sambhavi? Substring, not character. They are asking for character only. Your task is to find the lexicographically smallest substring with the maximum frequency. Yeah, that is also fine. The same way it would go. The same way. Okay. So second problem was DP. Yeah, it is substring. I understand. But the solution would be absolutely the same one. It won't make a difference. Okay. Substring can be a character also. Yes, absolutely. I think we are good enough to move forward. Let me just share the tab so that you would have a better visibility. Okay, I think you are good to go. You can treat it as a character only. So I'm a very lazy person, so I won't be hitting the tab again and again. So that is why I would be making like this. Okay. So now I would make an array of size 26, or better move forward with a vector. I'm more accustomed to using vector of 26 with the initial values as 0. Vector is already initialized with 0. You don't need to pay attention to it. Still, just do it. Okay. Now we move forward and we start the counting part of it. For int I is equals to 0, I is less than n, and I plus plus. Then what you need to do is you would just have frequency of s of I and then subtract the value of a. Okay. And then do a plus plus. Why? We are just incrementing the count of each character. Okay. Now the very next thing is that we would initialize a string. Okay. We would initialize a string of size 1 with the character as 0, so that we can just compare, because we are told to return the substring. Okay. And then we would just have frequency is equals to 0. Suppose we want to find the maximum value. If we want to find the maximum value, then we initialize it with the smallest value, so that even the small maximum would be taken into consideration. We do this now. Same way we would do it here itself. So now we would have it. For int I is equals to 0, I is less than 26, and I plus plus. Okay. So basically we are just iterating over the A to Z values. Okay. So now if, okay. Now f of I is greater than the frequency. Suppose the current value is greater than the value which we have saved. The earlier value is 0. Okay. So we would say, okay, see, this is now your current value. We would update it. Okay. And then we would add it to our answer. Answer of, okay, answer of 0 is equals to character I plus a. What do I meant by this? This just means that we are returning a string. Or basically what you can do is you can also, like, this seems a little bit confusing. Okay. So I would just return the answer. This seems a bit confusing. Okay. You don't need to confuse yourself so much. What you can do is you can simply have a character C. Okay. Simple. Have a character C. Okay. Whatever you are doing, character C, just assign it to it. And then at the end, to string, and this should work. Let me just see. Mhm. Char C is equals to A plus I. Let me just see again. No, this is not working. We are having the ASCII value of it. Character C, na? Okay. So what we would do is int val. Okay. We would have the val C is equal to val. Now this should work. Leave string AMS of 1 of size 1 with the initial value as 0, and we do it this way only. Okay, answer of 0 is equals to I plus A, and then we just return it. But the ASCII value is coming out. Okay. So basically you can just convert the ASCII value to a character, and but that would have the same complications. Okay. Like we are getting the ASCII value, but I thought that we would just get the character itself, but that would again come to the same conclusion that I would use a character, then convert it to a string. So same way, that won't be a good one. And yes, it's run. So tell me the line number at which you are not able to understand. Just tell me the line number. Typecast it to character. Yeah, thank you so much. Where we would find the Java implementation of this code? Array, you don't have array. Instead of vector, you just use array. Other than that, there is nothing to be specific of. String is also there in Java also. What does in? Okay, let's do it then. Char C, just type C is equal to character of this and then to string C. Mhm. This is not solving the purpose. Okay, what is meant by that? Let us explain you that only. Let us remove this. Let us again compile and run, and then I would show you. Answer is equals to. Okay, so this just basically means, you know what? This just basically means that we have a string of length 1 and we have initialized some value. Okay, like suppose एक blank string का length ले लिए, उसमें सब में a भर दिए. This is just like the same thing. Like if you just print it, let us print this. Okay, cout ans at this point only, and you would see that we have just the print of a simple 0. Just see what does this mean. See, this is a simple 0, a string of length 1 with the initialization of 0. This is just this. Array, leave it. It is easy. It's better that I explain instead of the experimentation and all. Line number 23. Okay, what is line number 23? Let me just see to it. Fri is equals to this. So suppose I I went to, this is something like, suppose I want the maximum value. Okay, I want the maximum value. But now suppose Kohli has made 105, which is more than Dhoni. Dhoni was 101. So now Kohli is better. So in the same manner, the current maximum is stored in FRE. FRE is the maximum, current maximum. So if the current value, that means suppose Kohli is scoring 105, which is greater than 101, so we would update the value. This is just like updating the value. सपोज क्या होता है आजकल के डेट में क्या होता है suppose we find a better person, we move to that person. This is the era of relationship in today's. In the same manner, if the current value is able to find a better value to be the maximum one, then obviously he is going to move forward and he would be updating it. Okay, now give me a quick one. Line number 23, Abdul Mukeed Munshi. Give me a quick one. So what if we did 4x? So the string would be xxx, right? Sure. Yes, absolutely. This is correct. I did and it worked. Yes, absolutely. It would work. Please skim through easier problems faster. I think everyone has solved this problem. Okay. But see, the thing is, if you just observe the comments, okay, to be honest, I too know this. But the thing is that many people are taking resolution on this day that I would start coding. And if you observe, there are some people on the comments also. They are saying that I have not solved any problem. Have you seen it? Like I have seen it, to be honest. Okay, that is why I'm just allowing them. or I'm just acting as a source of motivation. Like unko, like first, if you are able to understand the first problem, the first few days are absolutely very difficult. No, that is why I'm helping with that. So can you dry run with some examples? See, some people are asking for dry run also, so I can't skim fast. No? Suppose this is just like this. See, suppose we have one, two, and then suppose one, and then suppose five. So first we have the maximum as zero. I saw five. I saw five. Then I saw, okay, I saw one. Suppose initial maximum is zero. I saw one, and then I said, okay, one is greater than zero. So one is now the value. Okay, now one is the value. I went to two. Now two is better than one, so I went forward and made to two. Now two is the again same, so I would just leave it as it is. Three mila. Three to better hai na? So I would have this. Okay, then I would have one. One is less than three, so I won't do anything. And then I saw five. Five is better than three. So now this is how we find the maximum value. Okay, this is finding the maximum value in an array. Just solve it and you would be able to do it. Okay. Anything else? सर हिंदी में समझा दूं? थोड़ा आगे बढ़ रहा हूं, जो बेटर मिल रहा है उसे रख ले रहा हूं. ओके, बस इतना ही है. Okay, chalo, we would now move forward. We would stop the screen sharing. What is the name of the next problem? Quickly tell me the name of the next problem. Okay, everyone clear with this or not? Give me a quick 0 or 1 in the chat. Just give me a quick 0 or 1 in the chat. Everyone is clear with this or not? Okay, then okay, my mistake. Give me a quick 0 or 1 in the chat if this is clear or not. But quickly tell me the name of the next problem, because a good tree and most and least tasty. Most and least tasty. Okay. Chalo. Share screen, Chrome tab. Quickly recapitulate the problem, and then we would move forward. This problem, this problem was a very easy to crack. Like if we just see, if this was telling us that karke batao, this is telling us that yes, only we need to return the how many operations do we need. But if we were told that how will we do it, then it would have been a little bit on the harder side. ओके, थोड़ा थोड़ा समझ आया. ठीक है, आपका इनिशियल डे है, थोड़ा थोड़ा समझ आना ही इंपॉर्टेंट है. पहले दिन सब समझ जाओगे तो ये इजी बन जाएगा. इजी बन गए तो सब कर लेंगे. थोड़ा हार्ड है तभी तो सब नहीं कर पा रहे ना, वरना हर गली में कोडर होते ना. चलो, quickly read the problem. Okay, are you done reading the problem? Let us move forward. Chalo, this problem is interesting. Okay, so let us start this. Chalo. This problem is telling us something. Okay, this problem is telling us that we are given a tree. Okay, we are given a tree like this. Suppose this is the given tree. Okay, very awful in drawing, but that would work. Okay, so we are given a tree, and what we need to do is we need to tell the number of ways to make it a good tree. Now, what is a good tree? A good tree is where the frequency of leaf is less than the frequency of non-leaf. Am I saying the correct definition? Let me just recapitulate now. Least and most twisty. I explained the wrong one. Least and most twisty ना. Okay, चलो यही वाला बता देता हूँ. Let's keep this. Okay, so this problem is telling us that a person wants to gift a chocolate. Okay, and we have the values as A1, A2, A3, A4, A5, dot dot dot. Okay, but for simplicity, we would just keep five elements. Okay, now we are told that we need to partition the elements into k pieces. Partition the element into k pieces. Now, the very next thing is that you can't shuffle the ordering. The ordering should be intact. We can't shuffle the ordering. This is the very first scenario. You can't ignore any chocolate. Okay? You can't leave any chocolate. पूरे को पार्टीशन करना है, कोई एलिमेंट इधर उधर नहीं करना है. These are the two constraints. एंड जितने पीसेस बोले गए हैं उतने ही करने हैं, एग्जैक्टली के पीसेस, नॉर मोर, नाइदर मोर नाइदर लेस. Okay, I should be clear with this. So it's just like this. Suppose if k is equals to 3, then we need to partition it. To partition it, suppose I partition it like this. Okay, three values. Now, okay, so that we need to partition. But the problem is asking me that partition, हर partition का taste, the taste of each partition is something like this. I would just show you. Suppose I partition here at this point. So the taste of this would be A1 plus A3. It is just like this, that last value plus the first value. This is the taste. Okay. Suppose at this side also, suppose this is the partition. So the last value would be 4 and 5. There is one more interesting thing to note here. Suppose I add one more partition over here. So this partition, the taste of this partition would be A1 added to A1. Why? Because the first element is also A1, the last element is also A1. And this would be the scenario. Okay. So now the question is asking me for maximum taste minus minimum taste. What is the maximum minimum? The sum of taste of all the partition is the taste, and sum of all the partition the same way would be the minimum. Now we need to partition in two ways. First is to partition to have the maximum value. Second is to partition the cake in minimum value. मतलब करना है. How to do it, we would talk about it. But is the question clear? What to do, is it clear? करना क्या है वो clear हुआ? Just tell me quickly. Give me a quick. Okay, अब सही है. सही, मुझे लगा ही था. Okay, everyone is clear with the question? Please dry run real life example with k is greater than 2. Okay, I would do it. Why not? Can we do one dry run? Yes, absolutely. So let us do a dry run. Absolutely. Let us see this. Chalo. Okay, we need to do a dry run of k is equals to 2. Let's see this. Okay, so now if you just observe this, then how can we just try to have the difference? Okay, so we can see that we need to divide the chocolates into two. Okay, so let's talk about having the maximum taste first. Having the maximum taste. Okay, if we want the maximum taste, okay, if we want the maximum taste, then we would need the sum. We would need the sum to be maximum, like each element should be maximum, then only the resultant value. अगर समझो मेरे चार बेटे हैं, suppose I have four children, okay, and I want the success of mine through my children, so everyone needs to be equally good na. So in the same manner, if I want the resultant maximum to be good, then I would want every partition to perform the best. Like every partition would have the maximum taste. Karunga na? Is this true or not? Just let me see if I'm sharing the screen. Yes. Okay. Fair enough. Now what I would do is I would move forward and I would try to have the maximum resultant value. So if I want the maximum value, how would I do it? So see, 3 and 1, this would have a difference of 2. Okay, this is giving us a good one. 3 and 1, no, it is not performing good. So I would say that the first partition would consist of 1 2, the next partition would consist of 3 1. So the sum from this point would be 3. Okay, sum from this point would be 4, so the total sum would be 7. Okay, I want it to perform very well, na? That is why. So if I just perform, okay, now let's talk about the minimum value. So first tell me if the maximum is clear or not. Because I would try to pair up one with something big and one with three also. Okay, and I need to take every chocolate. So first or last element बहुत important. If you just observe, the first and the last element are absolutely very important. So when you want the maximum value, try to take the first and the last value very good. Okay, like they should be a little bit large enough. Okay, but we don't have a choice over the first and the last element. First and the last element would be definitely be taken. Okay, so we can decide on the middle children. Now tell me if this maximum thing is clear or not. Give me a quick yes or no. Anyone from Tamil Nadu, Coimbatore? People are seeing from Tamil Nadu, Coimbatore also? काफी बढ़िया. Okay, I would do a dry run. You don't need to say me, please. Mhm. Okay. Please tell me once again. 45535. So k is equals to 4. Okay, I would just answer this. Love from Odisha. Okay, good one. Jaipur. Okay. Fair enough. Let's move forward and just quickly solve this for the minimum one. Suppose I want the minimum one. Okay. Suppose कि मैं चाहता हूँ, like suppose I want my children, suppose I want my children's, suppose I have four children. Okay, I am a father of four children, but I am not. I am still a college going student. Okay, and I am still not married. Okay, let's take a hypothetical situation, and it is a hypothetical situation that I have four children, and I want my expenditure to be absolutely minimum. If I want my expenditure to be absolutely minimum, then each of my children should spend very less. Each one of them is very important. In the same manner, I want the minimum value. If I want the minimum value, then I would want the first and the last value of the part of each partition should be absolutely very less. Okay, like what is the value of a partition? Value of a partition will be, what is the contribution from a partition? Contribution of a partition would be the sum of first and last element. If first and last element is giving me the taste and I want it to be minimum, if first and last element is giving me the taste and I want it to be minimum, then I would try to have the first and last element very minimum. अगर एक पार्टीशन का टेस्ट फर्स्ट और लास्ट एलिमेंट डिसाइड कर रहा है, तो हम कोशिश करेंगे कि पहला और आखिरी एलिमेंट सबसे छोटा हो. I would do that, na? So in the same manner, what I would do is I would take this value. So for this and just take this value. Okay. So this would contribute 1 and this would contribute 2 plus 1, that is 3. So 1 plus 1, that is 2. 1 plus 1, because the first and last element would be same. So 1 plus 1, 2. 2 plus 1, 3. So 2 and 3, the sum would be 5. Earlier the sum was 7. So 7 minus 5 is equals to 2. Maximum minus minimum is equals to 2. समझ आया? Let us take one more example of the viewer. What was it? Okay, same thing. Okay, like I didn't draw too much, so I don't think that would be an issue. So what was this? 45535. Don't worry, we would take one more example and it would be clear. 45535. Okay, and k is equals to 4. Okay, chalo. Now the very first thing. Okay, so I want k is equals to 4. So I want the maximum value. Okay. If I want the maximum value, then I would try to have the first and the last element very good. So I would pair this with 4 and 5. 4 and 5, because 4 plus 4 is equals to 8. But I won't have it. I have better 4 plus 5 is equals to 9. Okay. Then 3 and 3 6. 3 plus 5 8. Okay. So we need to solve it. Okay, basically I can't just solve it manually. Okay, we need to see the test cases. So I don't know, but still I would just tell you, this is not the maximum. I can't guarantee you that this is the maximum because this is a new test case, because I don't have the correct solution. But what I can do is there would be a partition like this, that this would be one partition, this would be one partition, this would be one partition, and this would be one partition. I can have a partition like this. Okay, and the test from this would be 4 plus 5, that is 9. 5 3. 4 plus 5 is equals to 9. 5 plus 5, first and last element are equal, so 10. 3 plus 3 and 3, because the first and last element is equal, 6. 5 plus 5, first and last element is equal, so 10. So total test level is 9 plus 10 plus 6 plus 10. Okay, am I clear with this or not? Give me a quick one in the chat. Give me a quick one. Board not visible. अरे समझ गए भाई, मेरा स्क्रीन इज नॉट विजिबल. अभी भी नहीं विजिबल था. दिस टाइम दिस वाज नॉट विजिबल. चलो बढ़िया बढ़िया. I think that this problem, this most and least tasty, should be the last problem according to me. यस यस, एक सिंगल पार्टीशन है. सपोज करो मैं अकेला हूं. ठीक है. सो लेट्स सपोज आई वेंट ऑन अ डेट by myself. Okay, like it's a solo date. So if it's a solo date, then I won't share the food with someone. I would order it, I would eat it, I would pay for it. So in the same manner, if the size of the partition is 1, then the first element is also that element, the last element is also that element. Okay, chalo, let's move forward. So let's talk about how to solve this problem. Okay, so first idea would be that I want the small and the large. Okay, like if I want the minimum. Okay, so let's suppose there are two dimensions of this problem. The dimensions are maximum minus minimum. So let's first talk about how to find the maximum. Let's say that minimum is not there. Let's first solve how to bring out the maximum test. Suppose I want to bring out the maximum test. So what is basically the test coming from? So basically the test is coming from individual segments. The taste is coming from individual segments added up. Suppose this is A, this is B, this is C, and we add up A plus B plus C. This is the taste. So as I told that every child of mine is equally important. I want my success. So basically I would want that each of my child should perform better. Okay, should be better. So now see this, what is how this A is getting built up. This A is getting built up. Okay, built from the first element and the last element. This is also getting built from the first and the last element. First and the last element. Is this true or not? Give me a quick yes or no. Like this first and last element is absolutely very important. Now, see, the thing is, if I want the maximum values, then I would just sort it. Take out all the values from the end. Start taking out all the values from the end. अगर बड़े values ही चाहिए, so why not sort it and take out all the values? But what would happen, Sorting would disrupt sorting would disrupt the orientation or the ordering. Sorting would disrupt the ordering, and this whole thing would be broken now because we want the ordering to be intact. Like ऐसा तो नहीं हो सकता ना, ये लास्ट वाला यहाँ कंट्रीब्यूट कर रहा है, ये फर्स्ट वाला यहाँ कंट्रीब्यूट कर रहा है, ऐसा नहीं होगा ना. ये किसी और के साथ, वो किसी और के साथ. This can't make a partition. Like what I want to say is, suppose there is 1 2 3 4, so I can't make a partition like this, na. I can't make a partition like this. Oops, I'm absolutely so bad in drawing, na. I can't make a partition like this. I can't make a partition like this. ये उधर जा रहा है, ये उधर कूद रहा है, ये उधर किध रहा है. I can't make a partition. So what should I do? Or sorting is not available. But see, but don't deny the fact that we still want the maximum values. Okay, we still want the maximum values desperately. Okay, like I'm so desperate for my crush. Okay, like बहुत desperate है, ठीक है. If I want something desperately, do I would try to have that thing right. So what I would do is, what are the things for taking out the maximum values? So first was that I can use sorting to have many maximum values, but that was discarded because the ordering would be problematic. What is the next way to find the maximum values? Like what are the different ways to find the maximum values? Like suppose I want many maximum values. So what is the next way? Like what should be the next thing that should pop in your mind if I want maximum values? Tell me that thing. Why? I don't think that it is something to be saddened. Like you don't need to care that what would happen. Okay, desperate like us for solving problems. Linear search ever, but TLE would occur. Yes, absolutely. So what would be the better one? Linear search over and over again would make the time complexity each time big O of n. We can't use binary search also because that works on a sorted array. A sorted तो possible है नहीं. Try to have a pattern like this, that yes, this would be the roadmap when I think. Yes, absolutely. The very next thing is priority queue. Okay, because priority queue even works on unsorted arrays. Like वो अपने से sort करके अपने पास रखता है. First thing. The very next thing is that each operation would have a time complexity of log b's to n. Okay, or log n. Okay. Bubble sort also has a time complexity of big O of n square. So वो तो और भी ज्यादा ऊपर चले जा रहा है. Sliding window, how would sliding window do it? No, sliding window won't be able to do it. What you are thinking is correct, but that is not the way. Like to find the maximum and minimum at each window, sliding window is not an option. Okay, so max and min heap is an option. Okay, so now The problem is very easy. Now, what we would do is we would keep we would do a cunning approach. Like this can be solved using dynamic programming. The greedy one is a little bit difficult. I would say you why. See, the thing is that if I start keeping all the values in a priority queue, okay, the same thing would happen, that this f would go with this one, this f would go with that one. Like it can be the scenario that suppose this is 7, this is 1, this is 5, and this is suppose 3. So it might be a scenario that 7 is getting paired up with 5 and 3 is getting paired up with 1. It might be a scenario. The same scenario might again occur. So what is the way to battle this? To battle this, the way to solve this is that we would keep the values of the adjacent ones. Okay, like problem kahan ho raha tha when we were skipping the elements. So what we can do is, if we keep the adjacent values, okay, in the priority queue, if we keep the adjacent values, what do I meant by adjacent values? I would just show you that 7, 1, 5, 3. So if we are keeping the adjacent values, that is 7 plus 1, that is 8, 1 plus 5, adjacent 7 plus 1, 8, okay, 1 plus 5, that is 6, 5 plus 3, that is again 8. So now you can see that the first 8 is comprising of 7 and 1. The next 8 is comprising of 5 and 3. So see, when we just merge the adjacent values, वो जो elements skip होने start किए थे, that would be prohibited. The skipping of elements would be prohibited because we are just attaching it. Okay, we are just attaching it with someone. Okay, like suppose I don't trust my girlfriend. Okay, suppose I don't trust my girlfriend and she is going out. Okay, and I am in a dilemma that what if her best friend would come and she would room with her. So what I would do, I would just go with her so that her best friend can't come. Okay, so in the same manner, we can just attach 7 and 1, 5 and 3 together so that we don't skip the elements. Am I clear with this or not? This cunning approach, this small cunning approach would just solve the problem. Just give me a quick yes or no. Okay, this ended in just a sec. Yes, this was no. Yes. So this small thing is saving us. Am I clear with this or not? Give me a quick one. Happy New Year, brother. Happy New Year, Shruti Tyagi. And backtracking, I saw similar somewhere we partition so that you can use recursion. So why are you thinking of recursion? Recursion has a very high time complexity. Let me just switch back to my router. Okay, the speed is absolutely great. We are having a 200 Mbps speed, and I think I shouldn't lag after a point of time. Okay, so second one. Okay, quickly tell me if this thing is clear or not. Give me a quick one. That why are we attaching the things? How the attaching is coming into picture? Just give me a quick yes or no. Nakaj, which problem this is? Just I join. Nakaj, you do coding every day. You can skip today. आज थोड़ा रेस्ट ले लो. रोज पढ़ते हो आप. Pairing discard skip. But what if k is great? Pairing discard skipping. But what if k is greater than 2? If k is greater than 2, that won't solve any purpose. Like that won't be a problem. Now for your sake, like you would be confused, like why this won't be a problem. This won't be a problem because we are not having a constraint that this we can't only take two elements. Okay, like what if like what are you lag is there, just let me reload it. Okay, now you won't have any lag because my speed is absolutely good at the moment. Okay, so now the question is that what if the scenario that we are attaching two elements, but what if the scenario that we have k is equals to n, like जितने हैं उतने ही partitions करने हैं. The thing would be that we still would be having our chance. Why? Because we would just take the initial elements and that would solve the purpose. Am I clear with this or not? Give me a quick yes or no. Just give me a quick yes or no. I don't know why StreamYard is not giving me speed today. Just give me a sec. I need to recharge 4G data voucher. I don't have much data. Okay, just let me do it. Okay, it's done. Chalo, we won't have any lag. I was not have like my daily recharge was over, so I had a recharge now, and I think that would be good. Chalo, let's move forward. So now the question is very easy. We would just start the coding part of it. Okay, I would just remove the screen, stop sharing, share the Chrome tab. Seems like we are having a lot of problem today. Seems like uh, today internet is also telling me that please don't teach, go out and enjoy. This is what it is telling. Today I think that this is telling me the same thing. So we would have min priority queue and a max priority queue. Okay, like min heap and a max heap, and that would solve the purpose. Okay, so we would have long maximum value and the minimum value, and we would initialize max is equals to min is equals to a of 0 with a of n minus 1. Why are we adding this? Because we already know that whatever be the scenario, the first and the last value would definitely be added. And I am making it everyone lowercase so that I would won't have to hit tab each time. So am I good to go or not? Just give me a quick one. Like everything is on pace or not? Like I think everything should be on sync. So I would simply have a priority queue. Of PQ. Okay, Q1. Okay, priority queue. Okay, and this is nothing but max heap priority queue. Okay. So we would just have vector of int and then greater, okay, greater of int, okay, fair enough. And then we would name it as q2. चलो हो जाएगा. So we want current element and the next element. So we would be only going till the second last, because second last पे जब खड़े होंगे तब next का ही बात करेंगे. Otherwise we would go out of bounds. Okay. So for int I is equals to 0, I is less than n minus 1 and I plus plus. Okay. And then we would push q1 dot push a of I with a of I plus 1, and we would just copy it, make it q2, and that would solve the purpose. हो गया. Now the question is very easy. We would start taking the minimum elements and the smaller elements. For int I is equals to 0, I is less than k minus 1. Why k minus 1? Because 1k is already taken from this. Okay. So k minus 1 and then I plus plus. Okay. And then we have the maximum value. So we would have max added to q1 dot top. Okay, because that priority queue by default has the maximum value on top, and then we would remove it also so that we can see the next element, q1 q1 dot pop also. In the same manner, min plus equals to q2 dot top, like it would store the smallest element, then q2 dot pop. Okay, and then we would return maximum minus minimum. That would solve the purpose. Mhm. So easy ki na. It's done. Tell me the line number at which you are not able to understand. If you are not able to remember this long syntax of priority queue, which is nothing but a max heap, don't worry. What you can do is, before inserting, multiply it with minus 1. After taking out, multiply it with minus 1. And the max heap would be converted to mean heap would be converted to max heap. Okay. Just tell me the line number or give me a quick one in the chat that this is clear, so that I would move to the next number. Why do we take k minus 1? We take k minus 1 because 1k is already taken. See, 1k is already taken. So after that, k minus 1 segments remain. Okay? K minus 1 segments remain. 1k is already taken. Am I clear with this or not? Give me a quick yes or no. So Kishan Kumar, Raghu, Shruti Tyagi, Sarthak, Jaya, GA20, Kajal, Andrew, Rupam. Quickly give me a quick yes or no. Line number 15. Okay. Line number 15, what is it? Line number 15 is that whatever be the scenario, both in max and min, a of 0, first and the last element would see. First or last element to definitely contribute karega na. Answer पे. Like what is the tastiness level? Tastiness is the sum of first and last. So जो last वाला segment होगा उसका last element तो last element ही होगा, array का last element होगा. जो first वाला segment होगा उसका पहला element array का first element ही होगा. So what I want to say is, for the each segment, for the first segment, the first value, this value would be the array's first value, and for the last segment, this value would be the array's last value. That is why this would definitely contribute to this. Am I clear, Rupam? 25% clear. चलो ठीक है, पहला ही दिन 100% हो जाए तो मजा ही कहाँ. Okay, give me a quick yes or no. Give me a quick yes or no. Tell me the point at which you are not able to understand, or give me a quick yes or no. Explain what is happening from 22 to 26. Logic. 22 to 26. Basically, we are just adding the numbers in pairs. Okay. We are just having the maximum value. We are just having a of I and I plus 1. Okay. We're just adding that value. Like what is happening? The first value is first maximum is taken, then it is removed. The first maximum is again taken, then it is removed. In the same manner, the first minimum is taken, then it is removed. Because there is no indexing in priority queue. If we don't remove the first maximum, we can't really go and see the second maximum. Okay. It is just like that. Just sorting के बाद large biggest value to small value. In the same manner, in the priority queue, we don't have indexing, so we need to remove the largest element to see the second largest element. Okay, am I clear, Manoj? Give me a quick yes or no. This year I'm planning to have a long beard, like I keep a stubble, but this year I think I would be having a long beard one. But I would see that if it is suiting on me or not. Like my attitude doesn't allow me, or my work doesn't, like this thing won't suit now. So I would see to it if I would look good with long beard or beard or not. So I think we are good to go to move forward. So no one is having any issues. Chalo. No, I don't think I would. I would first decide that I'm looking good or not with long beard. Like I'm a person who doesn't keep long beard. No, it won't be soon. It would take time. So quickly recapitulate this. I think I would need to move forward. Quickly just recapitulate this. Quickly. Quickly recapitulate. Give me a quick one in the chat after you're done. Give me a quick one in the chat after you're done. डन चलो एक बार पढ़ में एक बार पढ़ लिया तो दिमाग में आ गया चलो present the whole screen, entire screen, and it's done. Chalo. No beard. No. Please don't ask me to have a clean shaved one. You won't be able to recognize me only. Okay. Like when I would come, you would say, why Siddharth Hazra is not teaching us? And when I would open my mouth, then you would say, okay. The first thing is that everyone would just leave the class if you see me with no beards. Okay. Fair enough. So we are given a rooted tree. Okay, we are given a rooted tree. Then what we are told that we need to have, like we need to convert this tree into a good tree. And what are the minimum steps to do that? So we need to convert a boy into a good boy. And what is the minimum amount of time that you need to do it? Okay. So the same question is here also. You are given a tree and you need to tell me that what is the minimum number of operation to convert it to a good tree. Okay, simple. So now the question is that what is a good tree? A good tree is where the frequency, like am I sharing my screen? Yes, I'm sharing my screen. The frequency of leaf node. What is leaf node? Leaf node is nothing but the last node which has only one connection. Like if you observe, every node is having two connection at minimum two connection. Okay, apart from the root. Like this is also having two connections. This is also, if it is a complete tree, everyone would have three connections. But if even it is not a complete tree, it would have minimum two connection. What I'm trying to say is this, that see, this has two connections. Leave the root. Apart from root, any node which has only one connection is a leaf node. Apart from root, any node which is having one connection is a leaf node. So people who are single, I can say that they are a leaf node, and people who are in a relationship, they are non-leaf node. Okay. So we have whenever the frequency of leaf is great, frequency of leaf is less than the frequency of non-leaf. Am I correct? Let me just see. Good tree non-leaf node is greater. Yes. Non-leaf node, frequency of non-leaf node should be greater than the frequency of leaf. And what is the minimum step to do that? So if you just observe this tree, even if there are no test cases or something, even if there are no test cases, what would be the way to do it? If we just visualize and write the tree, this would become very easy. Very, very, very easy. Let me show you how. So let us count the number of nodes. Okay. So number of nodes are 1, 2, 3, 4, 5, 6, 7, 8. Okay. Fair enough. 8. So 8 leaf nodes are there. 8 leaf nodes are there. Okay. Done. Now, what are the number of non-leaf nodes? The number of non-leaf nodes are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay. So 7 are non-leaf nodes. Okay. 1, 2, 3, 4, 5 is 7. So here it is not a good tree. So how can we make it a good tree? You want to see? See, it is very simple. So it is given that what we can do is we can just take up any node and then just do a reattaching kind of thing. Okay, just we can take up any node, break the parent, and then we can reattach with someone else. Okay, we can. So the steps allowed is like, how can it wait? Okay, suppose I want my son to be obedient. Okay. So, and I have asked my teacher that make him obedient. Okay. So, what are the steps I can do? The steps I can achieve is I can have like, uh, let's just, sorry. Let me just drink water. Okay. Suppose I'm a father. I want my child to be obedient, and I have asked my teacher to make him obedient. By how? By beating him or scolding him. So, in the same manner, to make convert it to a good tree, here we are told that we can take up any node, deattach it, and then attach it to anything. Okay, we are told this. So if we are told this, then I would show you something. This is a leaf node. So see, you can take up this leaf node, attach it with this. So this leaf node would remain as a leaf node. But if you just observe that earlier this was a leaf node and this is now gone. This leaf node is now gone. So we have now one less leaf node. So now what are the number of leaf nodes? 1, 2, 3, 4, 5, 6, 7. Okay, 7 leaf nodes. And 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And this one would be 8. So now this is a good tree. So the solution to this is absolutely very simple. Okay, take up any leaf node, attach it with the next leaf node so that that becomes a non-leaf node, and one leaf node would be less at each operation. So अगर 5 लीफ नोड है, suppose we have 5 leaf node. So to remove 5 leaf nodes, how many operation we would require? We would require 5 operation only, because at each operation we would remove one leaf node. See, earlier we had, like I would just remove all of this. Okay, earlier we had 8 leaf nodes. Now we have 7 leaf node. Okay, so in the same manner, what I can do is, earlier this is now 7 leaf node. I can make it to 6 leaf node. So at each operation we are having, so number of leaf nodes. Suppose, what is the difference? How much do I need? Suppose I want 5 leaf nodes to be converted to non-leaf nodes. If I want this, I would require 5 operation. Okay, am I clear with this or not? Suppose मुझे 5 रुपए चाहिए, और हर दिन मुझे 1 रुपए करके मिलता है. So 6 रुपए के लिए 6 दिन. So what I'm trying to say is, suppose each day I would earn 1 rupee. So for making up 6 rupees, I would require 6 days. So in the same manner, suppose I want 5 leaf nodes to be converted to non-leaf nodes, I would require 5 operations only. Am I clear with this or not? Give me a quick yes or no. Like, this is very simple. So at max, we can half the original number of leaf nodes. Yes. Leaf node का नया definition. Okay, Aradhya is done. Am I clear with this or not? Give me a quick 0 or 1 in the chat. Give me a quick 0 or 1. Okay. Chalo. We are good to go. So now the problem is absolutely very simple. We would just generate the tree from this. And one more thing, how this tree is getting made. The parent of 1. So let me just show you how this tree is getting made also, because if you see this problem in the first scenario, this would be an issue. So what we need to do is, if we just see it, how, so 1 is not having any parent. 1. This is 2, this is 3, this is 4, this is 5. So parent of, so am I sharing? Yes, I'm sharing. So parent of 1 is no one. That is why it is -1. 2's parent is 1. 2's parent is 1. 3's parent is 2. 3's parent is 2. 4's parent is 2. Okay. 5's parent is 4. This is how this tree is being made. Okay, that is how this tree is being made. This is already a good tree, so that is why this won't make any sense. To be honest, they didn't have given a good input and all. Like, see, if you just see, if they had given a good sample test case, you would be like, you would crack the solution if you just observe, if they had given. Okay, so ho gaya. Let's move forward, share the screen, and let's do it. Okay, good tree. This should be the second problem now. What do you think? I think that this should be the second problem. Okay. Shallow. I would make this as P because I'm a very lazy person. I would have it as N. Okay, so I would say that if N is less than equal to, N is less than equal to 2, we would return a value as -1, and this would be done. Now we would have a vector of N, and this is just making the graphs. Okay, so if you're not getting this, okay, like this is a vector of arrays. If you're not getting this, go out and just learn about graphs. Okay, and you would see that this is how we make adjust, like, the values. Okay, so now we would move forward with I is equals to 1, because the first value is a root value and it doesn't have any parent. Okay, so I is less than n and I plus plus. Okay, so now we would say that g of I plus 1 dot pushback push back the current value, that is p of I. Okay, so we are having a undirected graph, so g of p of I. Okay, like I can go to my girlfriend's house, girlfriend can come to my house. This is a two-way road. So I plus 1 can be visited from P of I, and P of I can be visited by I plus 1. Okay, simple. Like either ways we can visit. Okay, so now we would say that the number of children, okay, the number of child is initially 0, and then we would start the counting of it. Okay, so we would start the counting from I is equals to 2, because the root can't be a child. I is equals to 2, I is less than equal to the value n, and I plus plus. Now we would say that if someone is having only one connection, then just add it. So we would say while g of I dot size, someone is having one connection, then we would just say that yes, you are a child, get added. Okay, so after this is done, what are the number of non-child? Total number of nodes minus child is equal to non-child. Agar if I have a small family, okay, and so I have a small family. It is not hypothetical. I have a small family, okay, and I and my sister are there. Suppose you want to know that what is the number of elders in the home. So if you just take out the kids from the house, the remaining one will be elders. So if you just take out the number of child from the number of nodes, then the remaining one would be non-child nodes. Simple. So non Cn is equals to total number of nodes minus the number of child nodes. Now I would initialize that how many operations are there. Now I would say while number of child is greater than, while the number of children is greater than non-child, and each point of time I would just add one answer. I would decrease the number of I would decrease the number of child, and I would increase the number of non-child. Because what was happening? One, see, when we were detaching a node, so one child was taken. That is why one child minus minus. Okay, and a new non-child node is getting born. So non-child plus plus. We have made one operation, so answer plus plus, and then we would return the value of answer. This is done. हो गया. हो गया means done. Let us see how many mistakes I'm making. Okay, seems correct. Chalo, done. Now tell me the line number at which you are not able to understand. Tell me the line number. Only 38 people are watching. मुझे लगा कि give me a quick yes or no that this last thing is. How are we handling the edge cases where the root node only has one edge, one child? Okay, like see, we are starting from I is equals to 2. See, that is why we are हम लोग root के पास जा ही नहीं रहे, and it is said that one is a root. It is said vertex 1 is the root. So if we know vertex 1 is the root, why to touch it? अगर मुझे पता है कि मेरे सामने पापा है तो हम पूछ के थोड़ी पूछेंगे कि पापा आप हो. We know that. In the same manner, if we know vertex 1 is the root, so we won't touch it. We would directly start from 2. Okay. अब बताओ. Tell me. Any more issues anyone has? Quickly tell me. So while you are just telling, I am just waiting. So I would just say it. So what happened 2 years back? So last year it was fine. Okay. Why do we use I plus 1 instead of I? Because see, see, the thing is, this is for parent of 1, this is parent of 2, this is parent of 3. But the indexing is 0 index, but the nodes are 1 index. Nodes, ये तो 1 का parent है. This is 2's parent, but the indexing is 1. That is why we are just adding 1 to the index, and that would be the thing. Okay? That would be the thing. Am I clear, Rishit? Just tell me the last one. Okay. So what I was telling, yeah. So I thought that I would tell you this. So today I came and saw that more than 60 people were watching the stream. Okay. And I got happy, to be honest. Okay. Because now you are giving importance. Okay. Like on line number 15. Okay. Like let this to be end. Yeah. On line number 15. I for I is equals to, for int I is equals to, because one doesn't have any parent. One doesn't have any parent. So -1 तो है ही नहीं. The first one's parent is -1. Is this thing important? One's parent is -1. Why are one's parent is -1 means what? There is no parent of 1. If we already know 1 does not have parent, why to make connection? We aren't. Are we making any connection in the tree? No, we are not. That is why we're skipping the first one, because it is -1. It is what is -1? -1 is to depict that it doesn't have any parent. So in the same manner we are doing it. Okay. This is intuitive, but can you give us a rigorous proof that this is correct? Yes, you can insert P1 nodes. No need to create adjacency list. Yes, absolutely. You can do a short dry run if possible. चलो वो भी कर देते हैं. Like this is already a node. Okay. So I would just do a dry run. So see, this is I is equals to 1. So this is 0, 1, 2, 3, and 4. Okay. Am I visible or not? First, see me this. Okay, I'm not visible. Let me share my screen. Okay, chalo. Let's do a dry run to this also. See, this is 0, 1, 2, 3, 4. We are coming at this point. So G of 1 would store 2. G of 2 would store 1 and 3. Okay. G of 3 would store just 2. G of 4 would store 2 and 5. G of 5 would store just 4. Okay. We have this. We have this from this. Okay. After this is a leaf node. This is a leaf node because size is 1. Size is 1. That is how we are finding out. So the number of leaf node is equal to 3. So now I would remove this. Okay, this part is done. Okay, the next part is the total number of nodes were how much? 5. So number of non-leaf node is equal to 5 minus 3, that is equals to 2. Okay. The number of leaf. Okay, so we need to exclude the 1. Sorry, we are starting from 2. So we would exclude the 1. So the number of leaf nodes would be 2. And number of non-leaf nodes would be 5 minus 2, that is 3. We would exclude the 1. Like we are starting the iteration from 2. We are directly not coming to 1. Okay. So after this point, we know that non-leaf node is equals to 3 and leaf nodes is equal to 2. So this won't work. So answer is equals to 0. No operation is required. Even if there were operation required, we would take one node and attach it to something else. Okay. Now someone was asking that yes, this looks fine, but is there is a rigorous proof or not? So we can't really prove it mathematically, Okay, but I would give you a glimpse of what I want to say. Okay, so I can have like this. Okay, I can have like this. Okay, I can have more like this. Okay, that is why. Am I clear? Give me a quick yes or no. बहुत मेहनत हो गया आज तो न्यू ईयर के दिन. Am I clear, Siddharth Singh? Give me a quick yes or no. Am I clear or not? Siddharth, rolling through time, Priyanshu Pathak and all. Okay. So, yep, I was saying, like, anyone has any more issues? Okay. This question seems easier than the second one. Yes, absolutely. Just the visualization is a little bit of the difficult. So, what I was saying is, 2 years back, 2 years back, when I I was coding rigorously. Okay, like at that point of time, there was goodbye, goodbye. Like what happens in code forces at the end of the year, we have a contest known as goodbye, and on 1st of January, we also have a contest known as welcome or New Year something. Okay, so what happened is I gave both the contest and I was super depressed at that time because all my life I am low on friend circle. Okay. Like I rarely have one or two friends. Rarely have one or two friends. Okay. Like I'm a very unsocial person. Okay. Or you can like yes, unsocial, not an introvert, but I'm an unsocial person. So what happened is I was very depressed at that point of time that everyone out there is enjoying and I'm still coding. Okay. Because earlier there weren't this much streams and all, no? So I was not aware that everyone out there is coding. But at this point of time, after 2 years, I still thank myself that yes, I kept the consistency at New Year and all also. Okay. Like I too thought it that everyone out there is enjoying his life. Everyone out there life is so good. And I'm still here hustling like hell. Okay, like at that point of time, I was not even earning. So I thought that why life is not easy for me. Like I too thought it a lot. Okay. But eventually, when I look back, it makes sense. To be honest, it makes a lot of sense that I still kept it. Okay. So the takeaway from this would be that if you are the same person who is still coding, who is still giving contest, who is still absolving all this, trust me, when you look back, you would be proud of this moment. Like, yes, you skipped everything because of this. Chalo, that's it from my side. If you have any queries or questions, you can ask me. Okay. So quickly ask me, and after this, I would just end the stream. So yeah, today you are skipping dinners for us. You will deserve something better, sir. Yes, to be honest, I thought that today I won't have dinner. You deserve something better. Might be the scenario, but I'm happy with my current situation. I don't feel like having. Okay. Anything else? I would wait for the next 1 minute and then I would turn off the session. Just give me a quick yes or no and then I would turn off the session. Okay, last 1 more minute. Wait. Chalo, I think that's it for today. Most welcome. Sir, I'm new. Please give some tips to keep continuity. Be disciplined, don't be motivated. Okay, like make a discipline in your life that you would solve this many number of problems, or you would do this, you would do that. No motivation would work for programming, I think. Okay, no motivation would be there. Okay, if you're on motivation, you would leave coding after 1 or 2 months. I have seen many people who have left coding because of this motivation thing. Okay, so if you're watching this stream in the recorded version, or if you were till this point of time, feel free to like and comment on the video so that the reach of this video could be increased, and you would give back to the community of this one. Like if you just, like if you promote all this kind of things, like this is done for free, the post streams and all. So if you promote this, I don't think that it would ever become paid. Okay, it's all about interest, it's all about discipline too. Interest mixed with discipline. Thank you everyone. Happy new year. So okay, non CSE branch student, come home and study. बीटेक में कौन पढ़ता है? Okay, so happy new year everyone. I hope that this year you get your dream placement. Take care everyone.